10.2 storage classes. From the day one, we have been declaring variables. In every program, we have declared variables. For declaration purpose, we are using this syntax. Is if we want to initialize, we are initializing float height 4.1 like this. Actually, this definition is not complete. As a matter of principle, this definition is not complete. In this, one missing part is there. What is that missing part? Here, it should start with a storage class. For every definition, start with a storage class. So, if you declare a variable with the appropriate storage class, it can enjoy some specific features. So far, almost 9 chapters, more than 100 programs we performed. Then, without this, how you could manage? That may be your doubt. Here, one thing I am telling you, if you don't declare the storage class, then default storage class is applied. In all these cases, mainly, we depending on default scope. Default scope is according to our expectation. That's why we don't bother. But if you learn the features and functionalities of all the storage classes, in some cases, in some programming situations, you have to expect some specific behavior from a variable. If you have to derive that specific benefit, then you must explicitly use the storage class. You should not depend on the default scope. Understand? In storage classes provides you some specific benefits. If you want the specific benefit, you must explicitly define the storage class. All these concepts you may feel somewhat abstract. Once you enter into this, you can understand it very clearly. And now you see, storage classes mainly defines 4 issues. The first one is place. The second one is longevity. The third one is scope. And fourth one is default value. By storage class, by defining the storage class, you can define 4 things. One is the place. Place, where place means place of storage. Place of, you can understand that, place of storage, where our variable is stored. As you know that from the beginning I am telling you, it is stored in the memory. Memory means what we call primary memory or RAM or read or write memory and RAM. And there is one more storage place, and that is very small one, and that is CPU registers. In one context, when I explained the compilation process in the first chapter, I explained about that. Thereafter, I never have a mention about that. Now, you can understand that there are 2 storage spaces. The main one is RAM, memory, random access memory or reader memory, write memory, primary memory, all are referred to this. And second one is CPU register. CPU, in order to perform its job smoothly, it maintains some registers, memory registers. Register means a small memory space. It maintains a set of those registers. So, you understand that we can define that. Either our variable should be stored in RAM, by default is stored in RAM only. In some special case, very rare cases, you may expect a particular variable is stored in the CPU register, you may derive efficiency of the program. So, the first one is place of storage. you can decide by storage classes. If you don't do anything, then automatically the default scope is RAM. Every variable is stored in RAM. Thereafter, longevity. Now, your program, this is the beginning of the program, this is the ending of the program. Here you may create a block. So, here you see whether if you define a variable here, it is local to a block, then its longevity, here it bonds, here it dies. So, where you declare it bonds, where the closing brace comes, then it dies. Understand, this is its longevity. But if you define something here throughout the program until program ends, program is terminated, it survives. It survives from this point to this point. Once control enters here, it gets life, and control crosses this one, then it dies. So, in this way, depending on the storage class, longevity you can define. Longevity you define. How long a variable survives, that is second thing. Third one is scope. Scope means in which area, in which region you can access and manipulate a variable. That means whenever it is alive, then only you can access it. So, the scope means in which region you can access a variable. This defines the scope. Suppose with reference to this, the global variable, anywhere in the any part of the program, from any part of the program you can access it. This is a local variable, its region is this. So, its scope is this only, this point to this point to this point is its scope. This, its scope is the entirety because it is a global variable. So, scope means the region in which you can access a variable, access and use a variable. Default value. Default value means in every for every variable you give a value. If you don't give value, which value is stored? That is default, more detailedly, default initial value. Default initial values also depending on the storage class. So, storage classes mainly defines 4 factors. The first one is place of storage of the variable. The second one is the longevity, how long a variable survives. And the third one, scope, in which region you can access and manipulate a variable. And the fourth one is default initial value of the variable, depends on the storage class. Here, now, I will introduce the storage classes. He provides totally 4 storage classes. The first one is automatic. Second one is static. Third one is external. Fourth one is register. Totally 4 types of storage class are provided by C, and these are represented by 4 keywords. Automatic is represented by auto. Static is represented by static. Extern is represented by extern. Register is represented by register. Understand? They have the unique set of features that we discuss in this chapter. So, these are all keywords. That's why those must be written in a lower case. Then auto, static, extern, and register. Then what we have to consider, how to define that, where we have to write. Now you see, auto, int, yes. Initialization is not compulsory. This is auto variable. Static, int, count. This is a static variable. Now, extern, int, A, this is external variable. Next, register int C, this is a register variable. So here auto is applicable by default. Actually, whatever variables we are defining so far in all our programs are auto variables. So if you don't define auto also, that is applied. That's why so far we are not defining, because whenever you want to use that, then you must know its features. Without that, you cannot use that. So now you are in a position, now you learnt all the elements, now you are in a position to understand any additional elements if I introduce. That's why so far I haven't introduced. But even though you do not know this, there is no loss, because by default auto is applicable. So in the remaining part of this chapter, we take up each group of these four types of storage classes and their variables, and discuss their features and functionalities in detail.